So welcome to another Machine Monday. I'm excited to be here in our R&D lab in India with my colleague Pannkaj, who's responsible for managing the destructive testing process for laser welding of cells that go into a battery pack that eventually end up in a vehicle. So Pannkaj is going to talk us through the process of what he goes through to test the integrity of a laser welding process. And we use this to ensure that the machines that we make for our customers on cell and battery pack manufacturing produce the best quality welds.
So first thing first is this is the first machine which is going to cut the dummy cells because we cannot cut the live cell.
So what is a dummy cell?
So dummy cell is only used to validate the laser welding in the destructive method, because as you know that we cannot cut the live cell.
Yes.
There are a lot of chances for the explosion. The function of these cutting machines to cut the dummy cells for the laser welding. This you can able to see this. This is the diamond wheel, and this is the fixture to hold the dummy cells. Right. And this is the sample preparation machine, which is very important in this process of the laser weld depth penetration validation. You can able to see. This is a sample which is coming out of this machine, but to do this, to perform this operation, we need to pour this powder. This is the Bakelite powder. We need to pour in this cavity and make sure that the cutting sample, what we have just got from the cutting machines, we need to put this cutting edge at the bottom, and then you need to pour the powder. Once you pour the powder, when you start this machine is having a pneumatic cylinder, hot pneumatic cylinder, which is there to have 15 to 20 minutes for around 160 to 200 degrees Celsius for 10 minutes. And once this machine operation is done, we can able to have this kind of sample with it. Because the next operation is to have that polishing machine, because the grain structure needs to be come out nicely. So imagine when the cutting machine is with the diamond cutting wheel, there are a lot of reburring is put into this.
So burrs on the edge.
So to remove that, we need to perform the polishing machine.
So the whole purpose of forming it inside this is so that we can polish it perpendicular. Okay. And obviously there's a fine polish here.
Correct. So if you see, so this is the two, for this polishing machine there are two aspects of it. One is rough polishing, after that diamond polish. So once we get the sample from the sample preparation, first we need to take it with this rough grinding. And when you see that this coming out nicely, then afterwards we need to put diamond paste over here first, and then we need to polish it till the mirror finish gets.
Oh, mirror finish.
So mirror finish is very important. Otherwise you cannot able to see in the microscope. Because we can say it's a 0.2, 0.3 mm. So it has to be mirror finish first. After coming out, this is the microscope. But before going into the microscope, there is one important aspect to perform. We need to perform the chemical etching on it. So why chemical
etching?
Yeah. So chemical etching is another broader level of science, I would say, in the chemical engineering, because every OEM has defined its busbar material. So before performing this test, this particular chemical etching, we have to ask to our OEMs or the customer what is the chemical composition of the busbar, because this plays very crucial role to have this perform chemical etching.
So for every bus bar, we're asking somebody to formulate the chemical for the etching.
Correct. So there is, I would say, this is not how this.
It's not off the shelf.
Yeah. So we need to prepare it as combination of the 2 to 3 chemicals, maybe carbon dioxide, like that, and then you can able to make it to suit the busbar material.
Wow.
That is very important thing in it. And when you have a chemical etching nicely, then you can able to put your sample onto inverter microscope, and then you can able to see in the microscope this kind of grain structure will form when you able to see this. But if you cannot able to do it, the chemical etching, you cannot able to see it. The chemical etching, and before that the polishing.
It exposes the weld depth.
Exactly. It performs the grain structure nicely.
What happens if you weld too far?
So the thing is, there are two main criteria where customer gives to us. That is the penetration depth and the burst pull out strength. So just imagine, there is at the battery center there is a cathode. So just imagine if the laser welding goes into the depth and it penetrates this layer, explosion.
Into the chemicals, and that creates fire. And I assume that obviously not deep enough means the bus bar is not welded on strong enough.
So that's very important.
And so when we are making our laser welding cells, how does this process help us?
So this is very important question that you asked. That before that there is no process to identify. We generally get, as per the experience of the controllers, to have that laser depth, and then we realize, or maybe we will take it typically. But machines, plays very crucial role because it gives us the I would say the flexibility to the control operators to take it. So we can start by setting our control parameters for the laser welding by slowly, and we will check it at our machines, and then we can able to satisfy the customer's demand or not.
So we're using this process to optimize the laser welding process, not too far, not too short.
Correct, and because if you are not these machines, we can no clue where we are going, and just we can meet to the accident.
So it's preventing us from being blind when we laser weld the tabs on.
Right.
So it's amazing.
Yeah.
Thank you, Pannkaj.
Thank you so much. Yes.